So in this video, I will be discussing Codeforces educational round 161 rate for division 2. So in this video, I will be discussing problem number A, B, C and E. So let's start with problem number A. The name of problem number A is tricky template. So basically we will be given three strings, string A, B and C. And they are also given a condition like string S matches with string T if the following condition matches. For example, if the ith letter of string T is a lowercase, then Si must be equal to T of I. Else, if my ith character of template T is the uppercase character, then my S of I must be different from the lowercase version of T of I. For example, if my template contains a bigger A, then my S cannot contain a smaller A. So they will be so this what they have said that determine whether there is a sample template T such that string A and B matches with it while string S or string C does not matches with it. So in short, what we have to do simply for every index, we have to find whether there is a single index such that my A of I and B of I is not equal to my C of I. For example, in this you can see my A is not equal to C and my B is not equal to C. So answer is yes. But in the second test case you can see my A is equal to this A, right? And my this A is also equal to this A. But we have to only find only single index for which my A of I does not matches of C of I and my B of I does not matches of C of I. So but in the third test case you can see my M and L does not matches with A. So answer is yes. I do not have to traverse further. But in the last case you can see my A matches with here A also. In this case my B matches with B and in this case C matches with C, which means there is not even a single index for which both the characters are different from string C. So in this case my answer is no. So basically it is the simple greedy problem. So if I show its code, the code is also easy. If for any point my A of I is not equal to C of I and my B of I is not equal to C of I, if any of the condition matches, then I will print yes and return from here only. Else I will print no and return. So let's now discuss problem number B, forming triangles. So it is very good problem. I like this problem very much because I have got two wrong submissions during the contest while solving this. So what is problem asking us to do? We are given some n number of strings, number from 1 to n, and each string represents 2 to the power a of I, which means if I am given a string a of I is equal to 1, then this means the length of that string is equal to 2 to the power 1, that is 2 only. If my a of I is equal to 3, then my length of the string will be 2 to the power 3, that is equal to 8. Okay, so what they have said, I have to choose exactly three strings which will form a degenerative triangle. A degenerative triangle simply means a triangle with a greater area than 0. So how many ways I can choose three strings from this current sequence such that these three numbers would form a triangle? Okay, so this is the sample test 6, 1, 3 and 2. So what is the biggest hint in this problem? So biggest hint to solve this problem is that my a of I is exactly a of I. Instead it is equal to 2 to the power a of I. So this is the biggest hint to solve this problem. So let's now discuss how to solve this problem. So for let's suppose I am given a string like a of like 1, 2, 3, 4. So what are the corresponding number? My corresponding number would be 2, 4, 8 and 16. So now tell me, in this whole array, can you pick three distinct sticks to form a triangle? And answer to that is no. Why so? Because you see me, what is the necessary condition to form a triangle? The necessary condition to form a triangle is that if my two lengths are this A and B, then its sum should be greater than the third one and its difference should be smaller than the C1. But you can see when all these numbers are in the form of 2 to the power, in the power of 2. So let's suppose I'm picking three numbers. Let's suppose it will be 4, 8 and 16. So let's suppose I'm picking 8 and 16 as A and B. So is 8 plus 16 greater than my 4? Yes, it is greater than 4. But is my 8 minus 16 minus 8 is smaller than 4? It is not. So I cannot make like this. Let's suppose I'm swapping A and B. I'm taking now like 16 and plus 4. Are these greater than 8? Yes, this is greater than 8. But is my 16 minus 4 smaller than 8? No, it is not. So it is also failing. So now the last edge case. Suppose I'm picking like, is 4 comma 8 greater than 16? The answer you said is no. Which means if I am picking any of the three distinct characters or three distinct sticks from my array, then my answer to that question is absolutely no. Because the logic is simple. Let me explain that in the terms of 2 to the power. So what is the necessary condition? My a plus b should be greater than c, which is third side. Okay. So let's suppose if I'm picking the smaller two ones, which are not the same. If I'm picking the smaller two ones, so how I can increase my subsequence, or I can say how I can get the sum which is equal to my largest one. So if it is in the term of 2 to the power, how I can get 16? That is 8 plus 8 only. Okay, these two number will be same, and there is no number which I can get between 8 and 16 because it's all in the power of 2. Okay, and I cannot get 7 also. 7 and 8 is also not possible. The least number before 8 I can get is 4 only. 4 plus 8 or 8 plus 8. But I am not picking the same numbers. I am all picking the three distinct numbers. So in this case you can see I can only get 8 and 4. And 8 plus 4 cannot be greater than the next power of 8. Then the next power from 8 is 16. And the sum of 4 plus 8 cannot be greater than 16. That is with 8 plus 8 only. That is only equal to 16. Okay, so here you can prove that this if my both if my three numbers are distinct, if my let's suppose if my A B C, if my both these three numbers are distinct, which means they are not equal to each other, then my answer is no. Okay, clearly my answer is no. If my if I am picking the three different numbers, then I cannot make a triangle using that in the terms of 2 to the power. But no, the answer exists in the case where I am picking the same conditions. For example, in the same you can say 1 1 1 1 1. Their total 7 1. Okay, okay. So now you can see I can make a triangle. Let's suppose my A and B again. I'm picking the same number. Let's suppose 1 plus 1. Is it greater than 1? Yes, it is greater than 1. And 1 minus 1. It is smaller than 1. Yes, it is also smaller than 1. So when both the condition matching, which means I can pick three ones. So what are the number of ways I can pick three ones from this? That is 7c3. That is equal to 35. That is equal to 35. Okay. So answer you can say that is 35. Okay. So this is the answer for this case. So let's suppose my next case is like 3, 2, and 1 and 3. What are the powers? That is 8, that is 4, that is 2, and that is again 8. Okay. So now you can know. Now you are now you know that I can pick I can pick only same numbers. I cannot pick distinct numbers. So the triangle would always contain two same numbers. So the same numbers are here 8, 8. Okay, so I will pick 8 and 8. So what are the other numbers I can pick? These are 4 and 2. Okay, I can pair with like 8, 8, 4 and also 8, 8, 2. So how many will this both satisfy my triangle condition? Let me check. Let it be 8, 8 plus 4. 8 plus 8, is it greater than 4? Yes. And by 8 minus 8, is it smaller than 4? Yes. And similarly in this case you can see it is also satisfying for 2 also, which means I can pick both of these number. So answer for this case is 2. But let's suppose there is another case. Let me make it here only for better understanding. Let's suppose there is another case like you did 4. So the power is corresponding 16. Okay. So now another pair would be 8, 8, 16. But will this form a triangle? And the answer is no. Why so? Because you can see my 8 plus 8 is not greater than 16. Instead, it is equal to 16. So I cannot make a pair. But the another condition is satisfying. My 8 comma 8 is more than 16. Yes. But my 8 plus 8 is not greater than 16. That is the next number. So you can see there's observation now again. let's suppose I'm taking two same numbers. Let it be a comma a. Okay, so how many pairs I can form? That is all the numbers which are smaller than a, that is less than a. Okay, but if I cannot make a pair with like a and the number which is greater than a, that is not valid. So so I have, so condition is clear to you. If I'm taking two same numbers, first condition is like I will only take two same numbers. I cannot make triangle with three distinct number. Okay, so in every case I will pick only three distinct numbers, two distinct numbers. And how many pairs I can form with two distinct numbers? That is all the numbers which are smaller than my number. For example, in this case, my this same numbers are 8 comma 8, and the number of pairs which are smaller than 8 are 2, which is 4 and 2 only. So I can make two pairs. Okay, so answer in this case will be 2. But you see, there is also another bigger number which is bigger than 8. So, but I cannot make a pair with greater numbers. So answer for this is no. Okay, so only 2 is now only 2 with only add in my sum. Okay, done. But there can also be case. Let's suppose there are total 4 eights. So they can also make a equilateral triangle. Both three of my sides are equal. Okay, so I can also make a formula like number of occurrence of 8, that is, let's suppose 4 say 3. So for each and every pair I will count its frequency and use its formula and C3 for each and every occurrence of this character, and count how many numbers are smaller than my corresponding numbers and multiplied with them. Okay, because you know let me now generalize the whole solution. Let's suppose there is a number x and its occurrence are, let's suppose, 8, and there are some and there are some five distinct numbers which are smaller than 8, and there are some three distinct numbers greater than 8. So how many possible numbers are there? So let's suppose, how can I calculate? I have total 8 numbers which are equal. Okay, so first of all I will calculate number of ways I can pick two numbers from these 8 numbers, because you know it at every point I will choose two distinct numbers for making pair with smaller one. So how many two distinct number I can pick? That is 8 C2. Okay, in short it can be written as 8 into 7 by 2, or generalized formula would be n into n minus 1 by 2. So these are total number of ways I can pick two distinct number from frequency 8. Okay, so how many number I can form now? I have chosen two distinct numbers. So for two distinct number I can make pair with five numbers, because five numbers are smaller than my current number. So I will multiply it with 5. Okay, and why I am not multiplying with 3? I have told you earlier, because greater value will not satisfy my triangle condition. So I will multiply it with 5. Okay, so these are the cases in which my two sides are equal and my another side is not equal. Okay, but there is also a case in which my three of the side will be equal. That is, it will form a equilateral triangle. Okay, so in the case of equilateral triangle, I have to simplify the number of ways I can choose three distinct number from 8 numbers. That is in short equal to n into n minus 1 into n minus 2 divided by 6. So this is the in short formula for this only. So number of ways I can choose three distinct number from 8 numbers. So final answer would be sum of this plus this. So this is how you can calculate the answer. So if I show its code, first of all, what is the most important thing? I will calculate the frequency, because you know frequency is playing the important role. So I will calculate the frequency. Now what I will do, I will simply find the number of ways I can choose three numbers among them only. For example, it is 8. So I will first of all calculate 8C3, and the formula would be n into n minus 1 into n minus 2 divided by 6 only. So I will add it in my answer. Done. Okay. Now what next? I will calculate number of ways I can choose two distinct number from my 8 numbers. That is n into n minus 1 divided by 2. Here, let this formula I will calculate. So now tell me how many numbers are smaller than my current number. I can simply calculate using binary search, using lower bound function. So using lower bound function, I will get the numbers which are the count of the numbers which are smaller than my current number, because I sorted the initial array. Then I will multiply the number of time I can choose two numbers multiplied with the smaller numbers. So answer for my three subsequence and two distinct subsequence will be my final answer. So hopefully you have understood the intuition of this problem. So let's now discuss problem number C. So now you can see problem number C is also a good problem. I like this also. So what is the problem asking us to do simply? So there are total n cities located on the number line. Okay, and if I can go to right city from my current city, or I can go to left city from my current city. Okay, but there is a condition. If the distance between my left city is smaller than the distance between the right city from the current one, then then using one coin I can move to the left city, or I can say like here I will understand. Let's suppose there is a city 3, there is a city at position 3, and there is a city at position 1, and there is a city at position 4. So the distance between 3 and 1 is 2. Okay, so distance between 3 and 2, 1 and 3 is 2, and distance between 3 and 4 is 1. So the city with the minimum distance, I can go to that city using one coin. Okay, yes, this is the condition. But let's suppose there is another case. Let it be 15, let it be 20, and let it be suppose be 14. So if my current if my absolute difference is smaller, I can go to the minimum. I can go to the nearest city using one coin. But if I want to go to the other city, which is not having the minimum distance, then I have to use some number of coins, and the coins would be the difference between them. That is the difference between them is 5. So I can go from 15 to 20 using 5 coins, and I can go from 15 to 14 to 1 coin. But let's suppose it will be not 14, but let's suppose it is 12. So now you can see the distance is again minimum. 15 minus 12 is smaller than 20 minus 15, which means the nearest place to 15 is 12 only. So I can go from 15 to 12 using single coin only once again. So this is the whole problem. So now we will be given some number of queries, and we have to tell what is the minimum number of coins I can use to grow from city X to city Y. Okay, so I can mark this as a brute force approach you can use, because I will calculate the always. Let's suppose there's an array like this. Uh, what is my array? My array is like 8, 0, 0, 8, 15, 12, and 20. Okay, okay, done. And the additional coin and the coin which is required to go to the nearest city is one only. Okay, now you tell me. Let's suppose the distance between them is not nearest. So then what will be the minimum coin I can use? That will be the absolute difference between them. Okay, and what is the minimum possible absolute difference between two countries? That is again equal to one only. So this will create an interesting idea to solve this problem. So I will first of all try to go from city 0 to city n. Okay, city 0 to city 20. So what is the amount required to reach city 0? Let it be, I will start from 0 only. Let it be 0 only. So now you can see, to go to city 8, I can always use one coin, because it is the only city which is near to it, and it is always equal to and it is always closest also. So I can use one coin to reach from city 0 to city 8. Now from go to city 8 to city 12, I can again use one coin. Okay, because you saw the difference between 0 and 8 is 8, and difference between 12 and 8 is 4. So the minimum difference is 4 only. So I can again use one coin. So to reach city 8, I am using one coin, and to go to city 12, I will use again one coin. That is total amount is equal to 2, because to reach from city 0 to city 12, the minimum amount of coin reward will be 2 only. Now if I want to go from city 12 to city 15, the difference between them is 3, and here difference is 4. Okay, now you see the difference is 3 again minimum. So I can again use a one coin only. So I will use, so the minimum coin required to reach city 12 is 2, and the minimum coin required to go from city 12 to city 15 will be 3 only. That is plus 1, because this is a minimum. Now in an interesting case, what is the difference between? The difference between them is 5. Now you see, if I want to go to nearest city, that is 12, but I'm not going backwards. I'm only moving forward only. So to go from city 15 to city 20, I will have to use 5 number of coin. So the total amount required to reach from city 0 to city 20 would be 8 only, because the minimum sum required at 15 point is 3, and to go from 15 to 20 I am requiring 5 coin extra, that is 8 only. Now you tell me, I have written the minimum number of coin required to grow from city 0 to city 20, or I can say the minimum number of coin to reach city 12 from city 0 would be 2 only. Now do you tell me, if from city, if I want to go from this city to this city, this is minimum distance, okay. Now if I want to go from this city to this city, this is also minimum. From this to this is also minimum. So does it comprises one more thing, like what? If I want to go from, it is 8, if I want to go from city get city 8 to city 15, that will be also be minimum. But why so? To reach city 15 from city 0, the amount required is 3. To reach city 8 from city 0, the amount required is 1. So to go from city 8 to city 15, the answer is difference between them, that is 2. So this is how problem intuition. I hope so you understood. So let me repeat it again. So I first of all I will calculate the minimum distance which is required to grow from city 0 to city 20, and I will store that number at every point, which comprises, if I go to from city 0 to city last city, I will require this much amount of minimum amount of coin. And also if I want to go from city 0 to any other city, the corresponding number is a minimum amount of coin which is required, which means if I want to go from city any between them, I will calculate the amount required from city 0 to that city to get the city, and subtract the sum required to reach the smaller one, because that is the absolute difference which I want to get the minimum number of coins. Okay, but that's another case. If I want to grow from city 15 to city 20, let me erase this part. If I want to grow from city 15 to city number 8, not vice versa, not from 8 to 15, but 15 to 8. So in this case, will it work? The answer is no. I will again have to find the reverse answer in reverse order. So how to find in reverse order? What is the minimum amount to reach 20? That is in backwards manner. That is 0. Now if I want to go from 20 to 15, the answer is 1, because the only adjacent to 20 is 15 only. Now if I want to go from 15 to 12, what is the amount required? The amount required is again 2, because you see the difference between 15 and 12 is more than 20 and 15. Now if I want to go from 12 to 8, what is the minimum amount required? So the nearest to 12 is 15. Okay, so it will took me to this direction, but I want to go to this direction. So the minimum amount required will be its difference, that is again 4 only. So 4 plus 2, that is 6. So the minimum amount to reach from 20 to 8 is 6 only. And to next I want to go from 8 to 0. So now you can see the distance toward 12 is minimum from 8. Now but I want to go from 8 to 0 in the reverse order. So the amount added would be difference between them, that is 8. So 8 plus 16, that is 14. Okay. So this is the answer is in reverse order, and this is the answer is forward order. Now if someone asks you what is the minimum amount to required go from 15 to 8, that is, first of all I will calculate the distance required from this place and this place, and subtract this one from the bigger one, that is 6 minus 1, that is equal to 5. So the minimum amount that is required to go from 15 to 8, that is 5. And if you want to go from 8 to 15, that is 3 minus 1, answer is 2. So that's how you can memorize the whole part and find the answer. So if I show its code, the code is also easy. First of all, what I'm calculating, first of all I'm calculating the minimum amount required from 0 to the last index. That is how I'm calculating. If my current difference is smaller than my previous difference, then I can simply add 1 in my previous answer, else I have to add the absolute difference between the next and current one. So I will return that part. Similarly, I will find the suffix answer also. If my current difference is smaller, then I will add only one, else I will add the whole difference, absolute difference between them, and return the suffix array. Okay. Now, if I'm in a query, if my x is more than y, then I will simply return the prefix of y minus prefix of x. If my y is greater than x, then I have to use suffix array and simply subtract suffix of y minus suffix of x. So this is how problem intuition of problem number C. So how you can solve this? So this is how you can solve this also. So this is how you can solve this also. So let's now discuss last problem which I was able to solve this problem set. That is problem number E, increasing subsequences. Okay, so this is also pretty much interesting problem you can say. So in short, what is problem asking us very simply, we have to find a subsequence in which my number of longest increasing subsequence, or I can say number of increasing subsequence, strictly increasing subsequence would be x, and my x can be as greater than 10 to the power 8. So let me discuss this, hurry up because my battery is draining. So now tell me, if I'm writing a sequence like this, 1, 2, 3, 4, how many possible subsequences can be there in this array? That is 2 to the power its length. Okay, but its length is 4. So 2 to the power 4 array are possible. So 2 to the power 4 subsequences are possible in this case. Okay, okay, now done, which is in short equal to 16, which means in the increasing order from 0 to 4, I can always get 16 number of increasing subsequences. That is, you can say, if I write a smaller test case, 1, 2, and 3, then you can see I can get a empty subsequence, I can get a single one, I can get a 2, I can get a 3, I can get 1 2 1 3, and last 1 2 3. How many are there? 1 2 3 4 5 6 7 8. That is 2 to the power 3, that is 8, which means if I'm writing my array like 1 2 and 3, I will get total number of 2 to the power 3, which is 8 number of increasing subsequences from this. Okay, so let me debug one test case how you can find the answer optimally. So the test case number 1 is 13. So first of all, I will calculate its binary representation. Okay, so the binary representation of 13 can be 2 to the power, I can say 2 to the power 3 plus 2 to the power 2 plus 2 to the power 0, which is 8, or I can say it is 2 only. uh, it is 2, yes, 2 to the power 4 and plus 1. Okay, and okay, so this is how I can get, which means to achieve a length of, so you can say I will break this part. First of all, I will try to achieve a length of 8, then I will try to achieve a length of 4, and at last I will try to achieve a length of 1. So how I can achieve a length of 8? So to achieve a length of 8, I can simply write in increasing order. So you can get 2 to the power 3, that is 8, which means a sequence like 1 2 3, that would generate total that would generate a total of 8 subsequences, which will be in increasing order. Yes, it will generate. Okay, now to add four more number of subsequences. So to get four more subsequences, how? So let me write it separately. So to get four more subsequences, you can write it like 1 and 2. So it will give me total number of four number of six subsequences, like a empty array, a single one, a single two, and 1 and 2. So that's how I can get a total four subsequences from this array, right? I can get it. But now you can see how, but in this case, if I write it like two single here only, okay. So this is the increasing subsequence. If I write 2 here, how many subsequences are increased? So you can see my this is forming total number of 8. Okay. Another pair I'm getting now is 1 comma 2 only. That is a single increment only, plus a 2 separately, plus 1, that is a 2. Okay. But now I want total number of 4 increments. Okay. How I can get a 4 increments? Because in this case you can see, to get a 4 increment, if I write it instead of 2, if I write of 3, then I will get a total of 4 increments. Why so? Because you can see my 1, 2, 3 is already there. Now I'm again adding a 3. Now you see my 2 and 1 are already repeated in these subsequences. That I should not repeat in this part. So to avoid that part, I will add another number, or either I can add another increased number. For example, in this case, to get a sequence of length 4, I have to use 1 comma 2. Okay, okay. But now you can say in this case my empty is already done, my 1 is already done, my 2 is already done in the previous subsequence only, which means I cannot make this part. Which means if I'm writing only 2, I'm only increasing my subsequences by 1 only. That is not desired number. If I want to increase to 4 only, how I can make it? Let's suppose I'm making like, if I want to increase total number of 4 subsequences, I will add 1, 2 and 3. So in 1, 2, 3, I will get an empty subsequences. 1, 2, 3 and a 1, 2 and a 2, 3 and a 1, 3 and a 1, 2, 3. But in this case you can see by my original array was this. Okay, my original array was this. In this original array, my empty array already come, my single one already come, my 2 already come, my single 3 already come. Okay, my 1, 2 already come. Okay, my all the subsequences have already come. So to increase the subsequences part, how I can increase? You can see my single 3 not come, because you can there will total 2 number of ones. I can, let's suppose it is already come, but you can see because my single one is already is also increasing subsequence, which means by I'm already getting all this part, which means if I'm adding a 3 here, I will be increasing total number of 3 numbers. But I am requiring 4 numbers. Wait a minute, it is 4 only, because a single 3 is also added, that is 3 part only. So you can see to increase a part of 4, I will add another 3 in the end. Okay, I will add another 3 in the end. So now you can see to I have achieved this part, I have achieved this part. Now to get another one in my answer, how can I get a last one? To get the last one, I can simply add 2 in the end, because you can see my here is 0, I cannot add a 0. I will add a plus 1 power, that is equal to 1. How? Because you can see my 1 comma 1 is not greater, my 2 comma 1 is not greater. So to the increase the subsequences, I will add a single one, which is only contributing itself in my answer, not with the previous number of form, with now not with any previous number. So wait a minute, let me charge this. Okay, I hope so I'm audible again. So how can I increase that part? So let me debug one more test case. How you can get an absolute answer? Let's suppose my current number is now 21. So how I can break 21 into? So which means I want at least 21 increasing subsequence in my answer. So how I can break 21? I can break 21 as a 16 plus 4 plus 1. Right. Let's suppose it would be 22 for a better test case. Let's suppose it would be 22. Now 16 plus 4 plus 2. Now the power of corresponding numbers are 2 to the power 4, 2 to the power 2 and 2 to the power 1. So okay. So first of all, I will try to make 60 number of increasing subsequences. How I can make 60 number of increasing subsequences? By writing 1, 2, 3, 4. Yes, I can make it 1, 2, 3, 4. So by writing this much in my array, I will get a total number of 16 increasing subsequence. Now what is the next desired number? The next desired number is 4. Okay, so how I can get a 4 increasing subsequences? So if I write it separately, I can write 1, 2. Okay, from 1 to I will get 4 number of increasing subsequence. But you know why? I will not write 1, 2. Because you see, the empty subsequence, a single 1, a single 2, or have already come in my this array. Okay, have already come in this array because a single one is already there. a single 2 is already there. And if I write none of the number, then it will be empty, then it is also there. So what is the purpose of writing this? So the only increased number would be 1 comma 2 only, which I am not getting, which is only plus 1 and not equal to plus 4. Okay, so how do I get plus 4? So to get a plus 4, I will not write 1 2, I will not write it is at a 1 and 2. I will also add a 3 in the end, because you can see by adding 3 in the end, the number of subsequences I will getting a empty, a single 1, single 2, single 3, and 1 2, and 1 3, and again 2 comma 3, and again 1 2 and 3. Okay, so now you can see my what are the repeating. My empty has already come, my 1 has already come, my 3 has already come, because you can see my this 3 has not come, because you may be confusing. 3 is here, but I'm not making it end, because you can see I am adding this current 3 in the end, so I will not mark it. The 1 comma 2 has come. Okay, my 1 comma 2 has come, because you can see my 1 2 3 4, so the total number of 1 2 3 4 plus 4. By adding a 3, by adding a 1 2 3 in my subsequence, I will get a plus 4 in my answer. So that's why I will add a 3 here. By adding a 3 here, you can see I'm getting an array like 1 2 and 3. So by using this array, or I can say by using this subsequence, I will get a plus 4 in my answer, and my plus 16, my plus 16 is also already this, and I'm getting a plus 4 by contributing 1 2 here and 3 here, another 3 here. So I'm done with 4 also. Now I want to get a plus 2. That is the last part which I want to get in my answer. So how do I get a plus 2? So if I write normally, to get a plus 2, I will only add a single one, because it will give me empty array and it will give a single one. But wait. If I want to get like this, if I want to get like this, you can see my empty array is already come. My one has also come, which means I am contributing plus 0 by adding a single one in my array. By adding a single one in my array. But you know why I want to add a plus 2. So how I can get a plus 2? To get a plus 2, I will not add a single one. Instead, I will add 1 comma 2, because you can see in 1 comma 2 what are the possible subsequences. The possible subsequences are empty array 1 2 and 1 comma 2. And what are the repeating? What are the repeated? My empty has already come, my single one has already come, but the two which I will be going to add has not come, and 1 comma 2, which is not formed by this but another pair like this. So what are these pair in this? So these two would be the single 2, and this 1 comma 2 would not be this, but instead it will be this one with this 2. That's how I'm increasing my pair. So this is how I can get a plus 2 also. So this is a whole problem division. First of all, for the first number, I will add the increasing number using that power only. Okay, I will add the number from 1 to that power. Okay, for example, it is 4. I will add 1, 2, 3, 4. But it is also for the largest power. Now for the all the previous power, I will simply add its power number plus 1, because you can see my 4 is 2 to the power 2. So I will not add 2, instead I will add 3. It is 1. So I will not add 1, I will add 2. So this is a subsequence which is having total 22 number of increasing pair. So how I can implement? You can simply implement this like this. You can use a bit set in C++, and for calculating its binary representation fastly. And what I am calculating? I am calculating from the last power. If my power is set, then what I am doing? I will simply adding from number from 1 to that power, that is from 1 to 4 in my answer array, and my changing my current state. If I'm getting another power which is set, then what I'm only adding, that is 1 I plus 1, that is the power plus 1. For example, it is 2, then I will add 3, answer is 1, then I will add 2 only. So in the last I will print the length and answer of my current state. So this is how you can solve problem number E also. So if you have any doubts in any of these four problems, you can comment me down. And till then, stay tuned for the next one. Thank you, and please don't forget to subscribe my channel.